All right, today I want to talk about section 2.6, associative and commutative properties of addition with decimals. We've been focusing on decimals, so we're going to be looking at these two properties through the lens of decimals, and they're important. This first one I want to talk about is the commutative property. And there's a word in here, property. There's a base word, commute, that I like to use that helps me remember what this word really does. And commute in the typical sense usually means when you go to work and back, or you go to school and back, but it's the driving to and fro places. And in this case, what it means is that if I have a set of things that I'm adding, I can flip the direction any way that I want. Flip the order of adding. Now, that's not the formal definition. The formal definition looks more like this. It says that if I have A plus B, that is equal to B plus A. And it's really simple. All that we're doing is saying that we can flip the order here and we get the same answer. If we look at a couple of examples to test this property and see if this is actually true, we'll always find it to be the case. I can say 2 plus 4 and 4 plus 2. In both cases, it will be 6. And what's even more interesting is that the longer I can have a huge set of things that I'm adding or even subtracting, and as long as I move them around correctly, I will always get the same answer. So this is our commutative property. It involves the moving of these numbers. The second one is our associative property. I often spell this one associative property. And the key word here is I think of is associate, or your associates. And those are people you work with or your friends. In this case, we're going to be changing who we group together when we are doing our adding and subtracting. So we're going to change the groups. In this case, I can say that if I write this A plus B in parentheses plus C, I can actually change the grouping of who I'm going to add first. I can say that instead, let's add A second and then B plus C first. But I'm really saying that it doesn't matter what I group, and I can even take away those groups. It doesn't matter because addition and subtraction are associative. That means that I can change their order. So let's test it out for an example. So I could say that 4 plus 2 plus 8, like this. Or I could say 4 plus 2 plus 8, like this. And if we add them separately, this is 6. 6 and 8 is 14. This is 10. 4 and 10 is, it's a terrible 0. 4 and 10 is 14. So of course they are equivalent in both cases. Now what you'll be doing for this section is simply, for most of it, identifying which property. And that's not a particularly difficult task. One other thing they'll ask you to do is they'll say, using some properties, simplify it and then find out what x is. For example, if we take a look at this, this will be our example 1. 1.94, that's not it, 1.94 plus 0.38 equals x plus 1.94. My key here is I'm trying to figure out what x is, of course. I'm always trying to figure out the value of that. And what I can notice here quickly is that, hey, there is a 1.94 on both sides of this equation already. That means that I can pull that out on both sides, and I know that the things that I add to those must be the same. So this and this must also be the same. So I can say in this point, x is equal to 0.38, because that's the only thing I can add to this side and have it also be true. I believe in all the ones that we're working on today, these will be equivalent. There will always be a number on both sides that you're able to add and build with like that. Okay, I'll do one more of these if you're like, what just happened? Otherwise, go ahead and go on if you're pretty confident. Let's look at this one. We have 0.8603 plus 0.292 equals x plus 0.8603. All right, so here again I can say, hey, these are both the same on both sides. So that means they are equivalent. And in the inside ones, these are also have to be the same. So I know that in this case, x is equal to 0.292. That's the only thing I can add to this number and have it be the same on both sides. If this was anything different, this would be either larger or smaller, so I know this must be the case. I hope that kind of makes sense. If not, ask a friend, ask me, and I'd love to help. Go ahead and good luck.